Well, hello. Today we're going to continue with multiplying decimals. So far we've looked at converting between fractions and decimals. Here we're going to explore multiplying these decimals and why we did that conversion first. Now there is a nice little method to doing this, kind of a shortcut or an algorithm you could think about, but we're going to explore why that algorithm works. Okay, and that's just like moving decimals. So to start out with, when we multiply by powers of 10, if you think about 0.423 times 10, we could write it out like this. 0.423 would be 423 thousandths times 10, and then we do a little, right, just like a little swipe. We'll cancel here, and then that takes us down to just 423 hundredths. So it went from 0.423 times 10 to 4.23. Okay, so let's keep that in mind as we begin to work through these. So here we go. 0.423 times 100. Well, just for simplicity's sake, we'll keep that. 0.423 we already said was 423 thousandths, and we'll take that times 100. You can always write these as any number as a fraction, just put it over 1. And then we can do some canceling, and I can go like this, and 2 zeros are gone. And now I get 42 or 423 over 10. Now last time we talked about how if this is tenths, then we would need one line after the decimal so that it's tenths. And I can start filling this in, and I would say that this is 3, and this is 2, and then we just keep going so forth. So we get 42.3. Okay, so 0.423 times 100 ends up being 42.3. Now this one, you might be able to figure out what's going to happen here already. Let's just make that a little bigger. Now the decimal goes away. Okay, so this is 423 thousandths, and we're going to take that times 1,000. When we do some canceling, look at that, it's all gone. We just end up with 423 over 1, which is just 423. Okay, so how about now? We've got 423 thousandths times 10,000. So now when we cancel, look at this. I can't even cancel all the zeros this time. I still have a 0 left here. So I'm just taking 423 times 10. And whenever you're multiplying a number by 10, you just add a 0, or you move the decimal to the right. But there's really not a decimal here. Not anymore, because we wrote it as a fraction. So that would get us 4,230. And then the last one, after you work that through, you're going to be taking 423 times 100, if you follow our pattern here. And then that's going to ultimately get us 42,300. Okay. All right. Now, sometimes we may not even write them all out like 10. We could actually just say 10 is 10 to the first, and instead of 100, maybe we write it as 10 to the second, or 1,000 is 10 to the third. And so if we want to evaluate this by 10 to the second power, this little 2 right here, this guy, all that really means is that we are going to move the decimal 2 places. Okay, that's what that means. We're going to move that decimal 2 places. 1, 2. So I end up getting 0.534, but after that decimal gets moved, whoops, let's get off of there. Yeah, that was rough going finding that. Okay, after that decimal gets moved 1, 2 places, we get 53.4. Okay, down here you'll see that we've got a 3 right here. That means we're going to move the decimal 3 places. That's what that means. So move 3 places. If we move this one 3 places, it's going to be 1, 2, 3, all the way to there, and that just gets me 534. If I take this one and I move it, I'm going to move it 4 places. So I'll move it 1, 2, 3, 4. I ran out of places to move it. 5, 3, 4, but I still have to move it one more place. It's got to go one more over here. So now this is when I end up just adding a 0, right? That's how I got my, that's how up here we ended up getting 4,230. We were able to just add a 0 there, right? And then of course this one we're going to move it 5 places total, which gets us 53,400. Okay, so our pattern here, if you kind of connect this idea of powers of 10 with what we were doing here before, then our takeaway is to just move the decimal right by the number of zeros that you have. So if we're multiplying by 10 to the 4th power, that we'd be multiplying by 10,000. That's 1, 2, 3, 4 zeros. So move decimal to the right, the number of zeros. Does that have an E? No. The number of zeros you have. Okay. I don't know why I put a period. That's not necessary. I guess that's a sentence. I didn't capitalize it. Move decimal to... It's not a very good sentence. So I'll call it just like a little phrase and get rid of the period. Sorry. Okay, so we're going to move the decimal to the right, the number of zeros that you have. If you're multiplying by 10 to the 5th, you move it 5 places. If you're multiplying it by 100,000, get back up there. I just say, oh look, 1, 2, 3, 4, 5 zeros. Okay, so I move it 5 places, right? If I'm multiplying it by 100, that's 2 zeros. So we move that decimal 2 places. That's how I got 42.3. So we just count the number of zeros that we have. Okay, so of course you can kind of look through this. This is that same idea. This is maybe just a few more examples that are all written out, so you can absolutely check that out. Okay, why don't you guys try doing these? I'll go ahead and pause it here. Just make sure you're good at moving decimals. Okay, pause this and then I'll get the answers put up here. All right, so the reason I like doing these is because I love multiplying by powers of 10. It's super easy. It's also the reason why I love the metric system so much, because the whole metric system of measurement is all powers of 10 and moving decimals. But that's neither here nor there. Congratulations, the rest of the world, for having a much superior measuring system than the United States. Sorry, I like the United States with a lot of things, but our system of measurement, I do not. Okay. 6.71 times 10 to the 4th. What we've got to do here is we're going to move it 4 places. So I'm going to do 6, 7, 1, and I've got to go 1, 2, 3, 4. So it's got to come all the way over to there. So this I'm actually going to move down here so that we can write our true answer up here. And that will get us 67,100 for the answer to that. And then down here, we'll move this. If it's 10, we just move it 1 place, and I get 0.349. This last one, I've got to move it 3 places, so 103.4. I've got to move it 1, 2, 3 places, so I got to put a couple more zeros on here, and that's how I get 103,400. Please don't forget your commas when you're talking about numbers that large. And we don't usually put commas inside decimals. So for instance, if I had 0.03496, we don't put commas here like this. That's just poor form. Okay. Sometimes you can put a little space there. That might help people's with their eyes a little bit. So like this. But we don't put commas. Okay. All right. Let's keep going here now. We're going to take this and explore what happens whenever we take two regular numbers and convert them to fractions, then multiply them, try to discover our pattern, and that's going to develop our algorithm as far as multiplying decimals quickly every time. So if I have 4 times 2, then that's just super easy. That's just 8, right? That's 4 over 1 times 2 over 1 equals 8 over 1. Okay, easy peasy. But this one, this is 4/10 times 2 over 1. Gets me, remember you multiply across the top for fractions, multiply across the bottom for fractions. That gets me 8/10, which means I'll have one decimal place after here. So this will just be 8. This is 8/10, 0.8. 0.4, well, that's 4/10. And this is 2/10. That's going to get me 8 and then hundredths. Okay, so that will get me 0.8, right? 0.08. Okay, notice the zeros here. Notice the zeros up here. Okay, let's go ahead and keep going. 0.4, that's 4/10. I can handle that. And this is tenths, hundredths, thousandths. So that looks like this. Well, I know the top is going to be 8. That's easy. And the bottom, I like multiplying by tens. That's 10 times 1,000. That's 10,000. So we get 8/10,000ths. 1, 2, 3, 4. Like this. Tenths, hundredths, thousands. Nope. One too many. Right? Did it just one too many. And I erased one too many as well. Tenths, hundredths, thousandths, 10,000ths. Okay, so you'll notice that I ended up with 4 places after the decimal. 1, 2, 3, 4 zeros there. Okay. All right, let's look over here at this one. 5 times 3. Okay, 5 times 3 is just 15. Easy enough. This will be 5/10 times 3/10 is 15/100ths. Let's see, I've got 2 zeros on bottom, and 15/100ths, I know I'm going to have two decimals. So get that. All right. Okay. 0.05, that's 5/100ths, and this is 3/100ths, and that will get us 15, and then let's see, I just count these zeros, right? Whenever I'm multiplying by powers of 10, we just count the zeros. 1, 2, 3, 4. Okay, so that gets me 15/10,000ths. There's 10,000ths, tenths, hundredths, thousandths, 10,000. So let's see, 4 decimal places here. 4 zeros, 4 decimal places. Okay, all right. So this is 5/1000ths times 3/10ths, and of course that will get me 15/10,000ths. Oh, no, wait a minute here. Oh, let's see. Right, same thing. Oh, so that's just 0.001. 4 decimal places again here for this 10,000ths with 4 zeros with 1, 2, 3, 4 decimal places. Wait a minute here. Let's see here. I've got 2 decimal places here, and I ended up with 2 decimal places in my answer. I had no decimal places here, no decimals in my answer. I had 2 decimals there, 2 decimals there. That means I had 4 decimals total that I was multiplying, and I ended up with 4 decimals in my answer. Oh, look at this. 1, 2, 3 decimals here, and 1 here makes 4 decimals total that I'm multiplying, and now I have 4 decimals in my answer. We could go back up and check all these too, but that pattern holds. 1, 2 decimal places, 2 decimal places, right? A total of 1, 2, 3, 4. A total of 4 decimal places being multiplied, and 4 decimals in my answer. Did you notice a pattern? I sure hope so. Stop moving around, computer. So here's maybe how we could think of it, is convert the numbers to whole numbers. So that's what we did ultimately when we wrote all these as fractions, right? we said that let's change this 0.05 into 500ths and 300ths. So we'll multiply 5 times 3 and get 15. Then we're going to end up moving the decimal back to the left, the same number of places we moved it in step 1. So we had to move it 2 places here and 2 places there for a total of 4 places. And that's why we move the decimal back 4 places, right? Or count the total decimals that you're multiplying. 1, 2, 3, 4. So we have 4 decimal places in our answer. Okay? All right, let's go ahead and take a look now at multiplying the types of decimals for the most part that you'll be multiplying from here on out, because we don't always multiply by tens. It's going to be that same algorithm, though. We're just going to kind of do this a little bit more streamlined. Okay. So when we want to multiply 0.5 times 0.7, we already did that, and we're not actually going to convert these into fractions at this point. What we're going to do is we're going to multiply 0.5 times 0.7, and now we think about, just kind of ignore the decimals. When you're multiplying, they're not all that important, right? 7 times 5 is 35, so I'll put my 5 here, and then I'll carry the 3, and 7 times 0 is 0 plus 3, okay, so 35. Now, what I think about here is, what I've done is I have 2 decimal places here that I've multiplied. So I need to have 2 decimals in my answer. Some people might think about it like this. If I actually just forget about these decimals entirely, I could take this as 5 times 7 is 35. And now I come back and I say, okay, well that's 2 places I moved it, so I've got to move it 2 places. Either way you get it, you're going to get 35. Okay, let's follow along with that one in green here. The one in red is how I do it, but again, that's because I've done these a long time. I'm very comfortable with that. So let's go kind of follow the green example here. If I move this 1 place to the right to start out with, I get 56 times 9. There's no decimals for you to keep track of anymore, like it was back here in the beginning. We'll come back to it. 6 times 9 is 54. 9 times 5 is 45. Plus 5 makes 50. Now, back at the very beginning was when we did this idea here. When we had to move this over 1 place, well, that means I've got to move the decimal back 1 place. Okay, we can't just move a decimal for no reason. We were just doing it temporarily. Okay. So that means that my answer will be 50.4. Now, keep in mind, there ultimately is 1 decimal place that we're multiplying in this problem, and we ended up with 1 decimal place in our answer. Okay. Down here, I'll move the decimal 1 place here, and I'll move it 1 place here for a total of 2 moves to the right. Now I'll take 51 times 45, and we just multiply. 5 times 1 is 5. 5 times 5 is 25. And then we multiply. 4 times 1 is 4. 4 times 5 is 20. 5, 9, 2, 2. Okay? And then, because I moved this decimal 2 places to the right from the get-go or from the start, I've now got to move the decimal 2 places back to the left. That gets me 22.95. Let's double check this and see, to confirm it, we do have 2 decimal places in the original thing that's being multiplied, and then I've got 2 decimal places in my answer as well. Over here, I'm going to move the decimal 1 2 places, and 1 2. That's a total of 4 moves. My answer is going to have 4 decimal places in it. And then we'll have something in front. Maybe it's a 0. I don't know, but I know that my answer is going to look like that. So 264 times 3. I mean, you could do 0, 3, but why not just do 3? So that's 12. Carry the 1. 18 plus 1 is 19. Carry the 1. 3 times 2 is 6 plus 1 is 7. So that's 792. And then I've got to move the decimal back 4 places. So 1, 2, 3, 4, all the way to there. That's how I get my 4 decimal places. 0, 7, 9, 2. And then again, don't forget it's always nice to put a number in front. So probably the best way to write this, we don't usually put those blanks. That's a little bit cleaner of a way of writing this. Okay. Now I've got 1, 2 places here and 1 place there. That's 592. And then we've got times 9. So 2 times 9 is 18, carry the 1. 9 and 9 make 81, plus 1 makes 82. And then 9 times 5 is 45, plus 8 makes 53. So we've got 53, but remember, we moved this 3 places to start with. So we've got to move the decimal back 3 places. So we're going to go back 1, 2, 3 places to there. That ultimately gets me 5.328. And again, just for confirmation, maybe if you were to think about doing this another way, we have 3 decimals that were being multiplied. Over here, these factors, there's 3 decimals total, and we have 3 decimals in our answer. Okay, the last one that we're going to look at here today in this part is 3.9 times 0.44. So this will be move it 1 place there and 2 places there. That's 3 moves. Right away, I know my answer is going to have 3 decimal places here. So we'll take 39 times 44. 9 times 4 is 36. I almost had a brain fart there and forgot that 9 times 4 is 36. If it's not, I'm sorry. We're going to keep going like it is, though. 4 times 3 is 12, plus 3 makes 15. 4 times 9 is, again, it's still 36, I hope. And then carry the 3. 4 times 3 is 12, plus 3 makes 15. And now we get 6, 1, carry the 1 that we're adding up. That's 7 and 1. Now, remember, when I go to fill these in, I'm going to have 6, 1, 7, 1. Right? Or you could think of moving this back 3 places, and that gets us our 1.716. And that's it. That's multiplying decimals. Okay? So make sure you get some practice in this. This is definitely a skill that you'll use in a lot of future maths and real-life applications, because money, frankly, like we use money a lot. Or if you're working in metric system of measurement, you do a lot more with decimals than we do in the U.S. customary system, because we use a lot of fractions. So that's another thing. Most people like decimals better than fractions. I'll get off my high horse on how awesome that is. But anyways, let's go. Good luck. I hope this was helpful to you.